Alright, so problem 1, we're going to use what we learned from our last video and apply that to this problem. And this is actually a warm-up so we can kind of get familiar with, these different number systems. Because I know it's going to feel weird because we're going to be messing around with the basics of our entire, math journey at the basics, at the roots. Yeah, so let's get started. Convert the following numerals into base 10 form. So we're actually not being asked about a lot. This is pretty simple. We're just going to look at these two numbers and convert them to base 10. So our first one, remember, do not confuse this with 1,110,101. No, remember, this is in base 2. So first, I'm going to write this out, but clearly. So 1, 1, 1, 0, 1, 0, 1. All right, so now I'm just going to go over what place values they are in. So this is in the ones place. This is in the twos place. This is in the fours place. Six. No, not yet. Eights, 16s, 32s, and of course 64. So these are all indexes of 2. So now what do we do next? Well, we look at these place values and we ask ourselves, how much is each of these worth? So let's first start with the most basic one. In the ones place, there is 1, which means that this is 1 times 1 right here. There is 1 of 1. That may be a little confusing, but let's continue. Now, this is just saying how much 2's there are. This is the place value, and this is how many of those there are. So we multiply 0 with 2. Then we have the 4's. So we have 1 4 because in the 4's place, there is a 1. So we have 1 times 4. And you can even do the rest by yourself. So 0 times 8. And, sometimes after you get really good at this, you don't even have to write down the zeros. But I'm actually just doing this so we can kind of see and visualize. Now we have 1 times 16, right? Because there's 116. Like there's one group of 16 plus one group of 32. And as you're doing this, it's important that you have to say it aloud so you really understand what you're doing, because you might get confused. And our last one, 1 times 64. Now this is actually its value, and this is going to be converted into base 10. So what's 1 times 1? 1 plus 0 plus 4 plus 0 plus 16 plus 32 plus 64. Now let me ask you an extra quiz question. Will you ever see the digit 3 in the base 2 number system? Correct answer is no, you will not. You'll never ever see the digit 3. In fact, you will not even see the digit 2. Because if it's 2, it's going to regroup, right? Because it is based on 2. So every single time you have a 2, there's already a new place value for that. So you're going to regroup. All right, now we add, right? So 32 plus 64. That is 96. 96 plus 4 is 100. And 100 plus 16, 116 plus 1, 117. So we can just fill our answer right here, 117, and I'm adding parentheses around it so I can write the bottom right 10. Okay. Clear some space for our next problem. Go right here. So we're converting this another problem here, 463. But it's not really 463, is it? Because it's written in base 8. Now we didn't go over base 8. So same steps, we're first going to write the digits out. 463. So this, of course, is the ones place. This is 8 to the first power is 8. So eighths, eighths, eighths. And this is the 64th. So this is 8 to the nth power now. So let me scooch this over just because we need more writing space. All right. Okay. So now same steps, right? We use multiplication. So 3 times 1 plus 6 times 8. By the way, I highly encourage you to do this by yourself and find the final answer because, we already did this together for the first one, plus 4 times 64. So we multiply 3 plus 48 plus now 4 times 64. That would be 240 plus 16, and that is 256. Now we add. So 256 plus 48 is 304. 304, I believe. 304 plus 3 is 307. So our final answer for this one is 307. But this is written in base 10. So of course, we also have a bottom right 10.